Hello my friends, we're going to talk today about the quadratic formula 9.2. The quadratic formula is the third method that we're going to learn for solving quadratic equations. In order to use the quadratic formula, you have to have 0 on one side. It's better, I think, if your lead term is positive, so that's the standard form. You identify the number coefficient A and B and C, and you stuff them in the formula, and then you simplify and you check your answer. Some people like to use mnemonic devices, and you can go on YouTube and listen to billions of people singing the quadratic formula to Pop Goes the Weasel, if you like. And this is kind of how the song goes there. So they're asking us here to use the quadratic formula to solve, so we're gonna do that. We notice that it's in descending order. We notice that our lead term is positive and it is quadratic, so it's degree 2. We got 0 on one side, so already step 1 is all done. So all we have to do is identify A, B, and C. So A is 3, B is -7, and C is 2. If you're wondering where this formula came from, right here, it came from completing the square in general. And you can Google, if you like, where did the quadratic formula come from, and you could watch a dozen different videos lovely videos that people have made on deriving the quadratic formula. And so that'd be great if you want. I think there's even a video that goes with your textbook, and so and you certainly can watch that if you like. So I'm practicing using the quadratic formula with you. I haven't derived it. If you want to derive it, though, you can certainly do that. Come to office hours and we'll derive it. Okay, so here we go. X equals, and so this is negative of plus or minus. I'm just stuffing in some parentheses in all these places, and then I'm going to stuff in the numbers there. So let's see here. This is B, and that was -7. And this is B, and that was -7. And this is A, so that was 3. And this is C, that was 2. And this is A, so that's 3. And then all I have to do is simplify it up. So underneath this square root, I have, and I can just put in exactly what I have underneath that square root, right? So I have -7 squared minus 4 times 3 times 2. So I have the square root of 25. So this is x equals, and this right here is a double negative, right, which is positive, 7 plus or minus the square root of 25 over 6. Now good news, the square root of 25 is 5. So x equals 7 plus or minus 5 over 6. And we're going to get two answers. One of them is when you have the plus. So that's 7 plus 5 over 6. So that's 12 over 6. So that's 2. And the other answer is when you have the minus. 7 minus 5 over 6 is 2 over 6, which is a third. So we have two answers. We have x is 2, and then x is 1/3. Those are our two answers. So we did a lovely job on using the quadratic formula on that particular problem. They're also asking us to use the quadratic formula on this problem. It looks like someone's factored it, but it doesn't have 0 on one side. So I do need to multiply this back together to get 0 on one side. So this is 2t squared plus 4t equals 1. And I want 0 on one side, so I'm going to subtract 1 from both sides. So this is going to be 2t squared plus 4t minus 1 equals 0. And A equals 2, and B equals 4, and C equals -1. So you get it in the form to use the quadratic formula, and then it's plug and chug, basically. So T equals, and remember our formula, negative of B plus or minus the square root of B squared minus 4 times A times C all over 2A. A was 2, so this is 2 here, and B was 4 here, and C was -1. So let's see here. When we simplify this up, we get t equals -4 plus or minus the square root of, and then this is 16, and then this is a double negative, which makes an add. So this is basically 16 plus 8, which is the square root of 24 over 4. Now, the square root of 24 is 2 times 2 times 2 times 3, right, is 24. And so for every 2 that are the same, one comes out. So this is 2 square roots of 6. So this is t equals -4 plus or minus 2 square roots of 6 over 4. And then you can simplify this. And so there's 2 ways of simplifying it. There's the triangle method of simplifying it, and I'm good with that. And the triangle says, what do these 3 numbers have in common, if they have anything in common? They have 2 in common. So you divide a 2 out of every single one of them. So this is t equals -4 divided by 2 is -2. 2 divided by 2 is 1, square root of 6. And that was a divide by 2 on all of them. All of my numbers that are not underneath the square root. 4 divided by 2 is 2. And then you don't have to write that one. So this is t equals -2 plus or minus the square root of 6 all over 2. And that's a good answer. And probably more people would write that answer than another answer. Another way of doing it, so this is an or, and your book does a little of both. So starting here, they say, hey, this is a binomial divided by a monomial. You can divide the pieces. So they do. -4 divided by 4 is -1, plus or minus. 2 divided by 4, those reduce and leave a 2 in the denominator, so square root of 6 over 2. These 2 answers for t are equivalent to one another. They look a little bit different from one another, but they're equivalent to one another. And there's 2 answers, right? There's -2 plus the square root of 6 over 2. There's no reason for me to write it in 2 pieces, although I certainly could if you wanted me to. I'm run out of paper here. So I could certainly write it as one answer looks like this, and then the other answer looks like this. Oh, and I'm off the page. So I could write it like that as my 2 answers, right? And so that would be certainly okay to do. Not necessary to do, because the plus or minus tells me use it at one time plus, one time minus. Okay, so we did a lovely job on that. If we wanted to find the decimal approximation to this, we certainly could, and I want to show you how to do that. They didn't ask me to do that on this problem, but I do want to show you how to do that. So you want to hit your fraction, and then I have here -2 plus the square root of 6 divided by 2. Now, when I hit equals, it says, hey, that's good. So no, I wanted a decimal, so S to D. And so this is approximately 0.2247 right? They didn't tell me where. If I want to find the other one, then I needed a negative in between. So let me go here and get a negative. And of course, it gives it back to me. And so this is negative 2.2247, it goes on. And so anyway, so that's the story on that. Okay, so 9.2 we're working on. So this is this next part of the assignment. The next part of the lesson is on how to decide which one that you're going to use. And so because remember that we had 3 methods or 4 methods depending on how you count your methods, and so The square root method is what I would use if it has a missing middle term, because you have to be able to get x squared on one side, and so if the middle term is missing, and a constant on the other. If I have the x term, then I'm not going to be able to get x squared isolated, having a variable, no variable on the other side. And so without completing the square, which is the method I don't like the most. So if this is the case, then this is solves easy and fast. And if you don't have a missing middle term, then you would have to use completing the square, which is slow and tedious. And so, and then there's the factoring method, and this only works if your quadratic will factor, and when it works, it's fast and easy. And the quadratic formula will solve all of them. So this will only solve some, this will only solve some, this will solve all of them. But if it has a missing middle term, this is easier. If it factors, this is easier. If it doesn't factor or have a missing middle term, then I can use the quadratic formula to find the answer. More people make little arithmetic mistakes on the quadratic formula than any other of the other methods. And then completing the square, and I only do completing the square if the directions insist. So I think it's the most tedious method. Some people love it, and so and you're free to love it. I don't, I don't require that people don't love a method. Okay, so when I look at this one here, I'm asking myself, well, what method would I use? So I can't use the square root method because it has a middle term. So that's the reason, that because of the 84x. And so I won't be able to get x squared all by itself with a number on the other side, because when I subtract the 49, I'm going to have that 84x, right? Because of the middle term, it's not appropriate to use this method. And I look at that and I say, well, it might factor, and it doesn't have a greatest common factor because 36 and 49 don't have anything in common, but it is a trinomial, and because this is a perfect square, 36 is, and 49 is a perfect square, I'm going to try the perfect square thing, and if that doesn't work, I'll go on and use the quadratic formula. So it's set up to use factoring. You got to have 0 on one side, so I'm just kind of like hoping this works. Now, I put this down and I'm hopeful, right? But I got to check and make sure that the middle term, I can see that the first works because that's 36x squared, hot diggity dog. But here, does that work? Well, that's 42x positive. And then right here we have another 42, positive 42x. And you notice when you add those together, you get 84x. And then last but not least, we get 49. So yes, hot diggity dog, it did factor. 42 plus 42 is 84. And so I was hoping that it would. It looked like it was one of those perfect ones. Because these are the same, I'm only going to have one solution. That's the only time that I only have one solution, is when those are the same. So 6x plus 7 equals 0. I'm going to take away 7 and divide by 6. So x equals negative 7 over 6. That's my one answer, right? So, and I used factoring to solve it. Now, if I had used the quadratic formula, and if you want to, you can go use the quadratic formula. Your A would be 36, your B would be 84, and your C would be 49. And go see that you don't get just one answer, negative 7 over 6. So if you wanted to do that, you certainly could. And then I chose not to use completing the square. And actually, this one was a perfect square when I factored it, wasn't it? Okay, so choosing a method. So I look at that one and I don't know whether it would be good to use what method yet. It's all still kind of half and a multiply. So let me multiply it together first. So this can be x squared plus x equals x minus 7. And it looks like it has a middle term. Do you guys agree? The middle term is the x, but you notice it's balancing the same amount on each side. And so what that means is that if I was to try to get the middle terms together by taking away x, both sides, I really don't have a middle term. And so I really get to x squared equals -7. And so that's perfect for the square root method when you have the no middle term, right? I have no middle. And so I'm like, yes, I'm going to use this method. All I have to do is use that property, right? X squared equals k becomes x equals plus or minus the square root of k. And so that's what we're going to have here. X equals plus or minus. So this is the story, the square root of -7. Now the square root of -7, the square root of a negative is I, and the square root of 7 can't be simplified. So this is x equals plus or minus I square root of 7. So we have two imaginary answers. So here, x to the third plus 1, this one's degree 3. It's cubic, it's not quadratic, so the others we've looked at have been quadratic. They have x to the second in them, that's what it means to be quadratic. So you want to get 0 on one side and factor it. So that's what you do when it is, that's what you do when it's cubic. And so I look at this and I think, well, can I factor that? And the answer is, yeah, it's a cube. And so you could whip out your cube formula if you like. So the cube formula, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So you might have memorized that formula. Maybe you have. And so I'm going to be using that to factor here. So this is x cubed plus 1 cubed. So where I see a, I'm going to replace with x, and where I see b, I'm going to replace with 1. So this is going to be x plus 1. And then I'm going to replace there, so that's x squared. And minus, and then this is going to be x times 1, which is 1x, so minus 1x, which is just x, and then 1 squared, which is 1. And so how this thing factors is x plus 1 times x squared minus x plus 1 equals 0. So when I go to solve this, this would be x plus 1 equals 0, or, and then x squared, remember that won't factor. Remember, because it came from the cube formula. And so I can solve this, it's linear. And I can solve this, it's quadratic, right? I can't factor it to solve it, and I can't use the square root method to solve it because I have the middle term, right? I have the middle, the minus x. It doesn't factor, so I can't use the factoring method. And so I can use either the quadratic formula or completing the square. The quadratic formula is plug and chug of completing the square. So you could, if you wanted to, give a try to your completing the square and see how you do on that. I'm not going to. I'm going to say a is 1, that's the coefficient here. B is -1, and C is 1. Everything's 1s here. So that x equals -b plus or minus, you know, I might go into a Pop Goes the Weasel singing here. So x equals negative, I'm going to run out of room, all divided by 2a, right? So I'm going to be plugging in there. I'm going to get my thinner pencil. I couldn't use this pencil really. Oh, it was the one that you couldn't see it. I remember that. You guys told me about that. We said A was 1 and B was -1. So in here is going to go -1. And in here is going to go -1 in the places that are B. 1 is A and C was 1. And so when the dust clears here, we're going to have a negative of a negative is a positive. So x equals 1 plus or minus the square root of, and then underneath here, -1 squared is 1, minus 4 times 1 times 1. So that's -3 underneath there, all divided by 2. And remember, you can pull out the I. So x equals 1 plus or minus I square root of 3 over 2. Now, if you liked, you could write this in complex form, which would be 1/2 plus or minus, and then it would be the square root of 3 over 2i, right? Remember, complex form was a plus bi, and so you could certainly do that. There's two answers here: 1/2 plus the square root of 3 over 2i, and 1/2 minus the square root of 3 over 2i. So altogether, we have three answers. There's two answers here and one answer there. So those are my answers, my three answers. Because it was raised to the third, I expected three answers. So here I had something that was raised to the second, and I got two answers, right? There's two answers there. But on this one here, it was raised to the second, and you guys remember that we had only one answer. The reason that we had only one answer is because it was repeated, this and that. So this says, hey, by the way, -7/6 is the answer. And guess what this one says? Hey, by the way, -7/6 is the answer. And so so the only time that you get one answer is when it's repeated. Okay, so we did a lovely job on that. Have one more to do. Doesn't look like it doesn't look like it's gonna fit in the spot, but we'll give a try to it. We did these actually in what chapter did we do the rational expressions? I got my book right here so I can look and remember. And we need to clear the fraction. So I look at that and I say, oh, I got a icky fraction. I got to get rid of that fraction is what I got to do. We did those in chapter 7 is where we did those. And so the common denominator, this doesn't factor, is x and then times x plus 3. So we're going to be multiplying by x times x plus 3. That's the lowest common denominator. And we're going to do that to every single piece. So this is going to be 1, and then I'm going to multiply that by x times x plus 3, and then equals 2 over x, and I'm going to multiply that by x times x plus 3, plus 2 over x plus 3, x times x plus 3. And there I am walking into my my words over there that says, hey, this is rational. You need to multiply by the common denominator, right? So when you multiply 1 times x, you get x. So this is x times x plus 3 equals, and then the x here and the x there, this is over 1, cancels with one another, and that's the reason I did that. And this is 2 times x plus 3. And then the x plus 3 here and the x plus 3 there cancels and gives 2 times x. So now I'm looking at it, I don't know if it's quadratic or if it's linear. Until I multiply it together, for sure, I won't know. Maybe you can see that when you multiply x times x, it's looking quadratic, right? X squared, and then plus 3x equals 2x plus 6 plus 2x. Right? And so when I combine like terms, I have x squared plus 3x equals 4x plus 6. And I can see that I'm not going to be able to use the square root method because I'm not going to get rid of the middle term, even when I rearrange it. So not the square root method because I have the middle term. Remember the ax squared plus bx plus c, this is the middle term, right? The one that has an x on it. Okay, and so I'm going to get 0 on one side because that's what I would do if I was going to factor it or use the quadratic formula. I haven't decided which one I'm going to use yet. So take away 4x and take away 6. So when the dust clears, I get x squared minus x minus 6 equals 0. And I'm looking at that and thinking, I maybe can factor that. And so 6 could be 2 times 3. And when I subtract those, I do get -1. So yeah, I could factor that, right? So I decided to use factoring. If you decided to use the quadratic formula, you would get the same answer. So I'm going to have x plus 2 equals 0, so that's x equals negative 2. X minus 3 equals 0, and add 3, I'm going to get x equals 3. So those are my answers. And that's what I used, was the quadratic formula. Factoring. If you wanted to use the quadratic formula, A would be 1, B would be negative 1, and C would be negative 6. And you can use the quadratic formula and verify that you get the same two answers. You should. Okay, my friends, well, that's enough videoing today. So that's 9.1 and 9.2 we did. And so far of chapter 9, and we'll look at 9.3 in the future.